Hello everyone and welcome to this new episode of our tutorial series on SALOME. In this new episode, we're going to see how to create groups using the Python API within the Shaper module. As we've seen together in the previous episodes, we have managed to create all these groups, as you can see here, using the graphical method, which is to select graphically the entities and then name them. Well, the alternative way to do it, especially when you have to do multiple group naming, is to use the Python API. One way to get it is to go to File, Dump Study, and actually save a file. Let's name it default dump, and we are going to see what it contains. So the first part of the file is dedicated to the import operations. We are going to import all the modules, tools, libraries that are needed. And then as soon as you perform any operation in the graphical mode, the Python API actually adds a new line with the operation you performed. Whether it was an operation within a sketch, as you can see here, the add sketch, or set coincident, set vertical, or any other operation on volumes, as you can see here, the add multi-rotation, add extrusions, all of them are written in Python in order to perform the same operations. What we're interested with here is the group creation part. So let me look for it here, group create, and here it is. If you look closer, the first operation is actually defining that the group will be constituted of solids, and then we are going to select, this is the model selection, the solid, which is the filter on solids, and then we say which compound we have selected. So this is the first operation, is actually to add the group, and then you have two operations that are set name and result set name. You may say, well, actually, this is doing the same thing. Well, not exactly. The first one, set name, what it actually does is create and name this group within groups here. And the second one, the result set name, actually creates a result of the group you have created. And this way, it will be accessible in other modules, such as mesh, for example. You may say in this particular case that the graphical method is actually just fine and quicker, and you might be right. However, if you look into the studs, you can see that we have 12 of them, and each one of them consists of 3 different parts. So selecting each edge manually, naming groups one by one, and repeating the same actions over and over again can quickly become tedious and time-consuming. This is where Python scripting comes in handy. With just a few lines of code, you can automate the entire process, selecting the correct geometry, creating the appropriate groups, and ensuring consistent naming. Let's take a look at how we can do that. So let's first find where it is done in here. So this is the stud naming. And as you can see, we have the selection of the 3 edges here. Then the group is added and the name is set once in the groups part and the second time within the results part. The exact same thing is done here for the second stud, selection of the 3 edges, adding the group and naming in the 2 parts. Let's now isolate these 2 and see what we can do to automate the process for the remaining 10 studs. Let's look closer to the selection operations. You can see that this part actually repeats itself through the 3 edges, and we are just iterating over the number of the edge. We could easily imagine a for loop that iterates from 1 to 3 in order to replace these snippets. Let's do it here. First, create a list for stud 1, and then create the for loop that iterates over the edge number within the range 1 to 4, which means we're going to have 1, 2, 3. And we're going to append each selected edge to this list. So let's pick this line, put it here and modify the last index, replace it with the edge number. Once the list is filled, we're going to use it as an argument here for this command to add the group. Let's copy this command, put it here and adapt it to our case. So in this case, it is about the stud1 group, and we're going to replace this group 16 objects with the stud1 objects that we have created. The remaining two operations are the set name and result set name. We're gonna copy them, put them here, and once again adapt them with the objects that we just created. So stud1 group will replace the group 16, and the rest stays as it was. Now let's use this snippet in order to create the stud2. Let's copy this, put it here, isolate the two parts. And now we're gonna replace all the 1 indexes with 2. So the first thing is to replace the list stud1 objects with stud2 objects. Next thing to do is to replace the index here with 2. Also, the stud1 group becomes stud2 group, and the name becomes stud2 instead of stud1. Once again, we can see that this name repeats itself here between the two studs. We just have the last index that changes between 1 and 2. This same index is used for naming the stud objects and the stud group, and finally also the name which will appear within SALOME. We can see here a clear pattern that could be used in a superior for loop that iterates over the 12 studs. Let's create it here. Stud number fee range 1 to 13. And once again, let's use this snippet and adapt it. Stud1 objects will be replaced with just stud objects. Also, the compound here, this index will be replaced with the stud number. Let's do it this way. So 1 is replaced by stud number. Also, the stud1 group becomes just stud group. The name here should be adapted. Gonna delete this index and replace it with the stud number. And finally, let's put all the stud groups into one final group. Let's create it here. Stud group, sorry. It's gonna be here. Stud groups. We are going to append the stud group that we created. Now let's remove all the irrelevant parts. This one and this one. We are left with this snippet, which essentially is a nested for loop. Let's imagine we have another variable, which is the count of the studs. 12 in here. We could directly use it in our loop and iterate over it. So this is a complete example of how to create groups, edge groups actually, using the Python API. We have applied this technique on the whole model, and this is the final result on our dump file that we generated previously. So we've done all the modifications in order to generate the groups automatically. You can find the whole file within the video description. And this brings us down to the end of this video. See you in the next one.